Hi class, let's continue on part F. Now, part F is asking for the residual for x is equal to 3. Because you're given x is equal to 3, the corresponding y value, it's going to be data that technically was collected. So in this case, 4 represents your observed value. Okay, so let me go back to the actual formulas. And here's the formula for the residual. Now, all it means is the residual is technically this distance from, well, the predicted y hat to a coordinate point that was selected. So you have to be given technically a value that was collected, and then, well, you should be able to find the regression equation, your y hat, and then you just evaluate observed minus predicted y's. But you're looking at the y's, but for a specific x value. So let me actually go back to this and let's actually rewrite it. So the residual, so let me rewrite it as residual for x is equal to 3. It's going to be the observed y minus the predicted. And I'm just rewriting the formula. So once again, let me point out to the formula. We're looking at observed value minus predicted. We only have observed. So far, the observed y value. So observed y value, we're looking at technically for x is equal to 3, your observed was actually 4. So in this case, your observed y is equal to 4. Now to find the predicted, we're going to have to evaluate y hat. So predicted y, and in this case, technically for x is equal to 3, we're going to be evaluating y hat, which is simply 1x plus 0.67, which we obtained earlier. And then you're just going to plug in y hat, which is equal to the values of 3 plus 0.67. So your y hat is equal to 3.67. That would be our predicted value. And in this case, this goes for this portion. And then, well, we were already given the actual value of the observed y, which was a 4. So in this case, your residual, it's going to be 4 minus the 3.67. So we're looking at 4 minus 3.67. Please evaluate that. I'm getting 0.33, which actually means that there is a distance of 0.33 from a given coordinate point to the y hat. So the y hat is your predicted line. That distance, so let me actually go here. The distance from the y hat to a given value of x is equal to 3. For the y coordinate, there's a distance of 0.33. So the calculation that we did represents this 0.33 value. That's what the residual represents. It's just the distance from any coordinate point to a predicted y. In this case, it ended up being 0.33. Let's actually move on to a prediction for x is equal to 6. So in this case, we're just going to be evaluating the y hat. This is equal to x plus 0.67. And we're just using the original part D, your y hat. So for x is equal to 6, we're just going to do a basic plug-in. X is equal to 6 goes here. So we end up with your y hat, which is equal to 6 plus 0.67. Your y hat is equal to 6.67. And then let me rewrite it that the prediction for x is equal to 6 is y hat approximately 6.67. And we always write these as coordinate points. So 6, 6.67. Those would be our technically prediction. We always rewrite it as a sentence because technically anything that we're doing with the y hat, it just represents a prediction. Those are values that we don't actually have. Now let's take a look for y is equal to -4. So we're going to start with y hat is equal to x plus 0.67. And then on this particular one, we're given that y is this value. So we would simply say that -4 is equal to, and let me rewrite it. So -4 is equal to x plus 0.67. And let's actually, well, in this case, subtract the -0.67, which is going to give us that x is equal to -4.67. That would be your predicted value. In this case, because the data set just represents coordinate points, we're allowed to have negative values. We don't have any units attached to any of these values. But if we had units like minutes, we couldn't have, well, negative minutes. So in this case, the prediction, so the predicted x for y is equal to -4 is x is equal to -4.67. And as a coordinate point, -4.67, comma, -4. Now I'm rewriting all of these as technically coordinate points. And also for this problem, we're actually use the fact that y represents y hat in your prediction. So in this case, I'm just going to leave it like this. -4.67, it's going to be our prediction for a y of -4. Now, for the last one, they want us to evaluate the following transformation. And this is your x's become 3 times x. So this is how we actually handle this one. Now, I need you to go back to the actual data sets and then go to a new list. Now, the transformation that we're told in here is that your x's have a multiple of a 3. So you're just going to go to L3 and then say 3 times your L1. And the transformation only occurs with the x's. You're not told anything about the y's. So you're still going to use the same, your same y values. So in this case, let me just rewrite it. So new x's 396. So new x values. So it was 3, 9, and 6. And let me just check it. Yes. Okay. So at this point, you're going to go to stats. And then you're going to do a linear regression t-test. But here we have to be very careful. You're no longer using your x's. You're going to be using L3. And then at this point, run it again. Don't modify anything else. This is going to be the new R value, which I think it's almost identical. I'll check it in a minute. So new R value. And remember that this represents the sum of x minus x bar divided by sx times technically y minus y bar divided by sy divided by n minus 1. And r ended up being 0.866 again. So approximately 0.87. Let me check the calculation that there was no errors. So you go to stats. Well, actually, let me first check that. Yeah, that would be 396. Okay, we're good there. And then run the linear regression t-test, which is here. And you're using your L3. So far, so good. And then calculate. We're just doing an operation on the x's, which is why we're basically multiplying it. In this case, our value of r didn't change, but you could end up with other operations where this either is going to get approaching 0 or it's going to get closer to the values of 1. In this case, that's the only operation that they're asking us to do. Basically, every x gets multiplied by 3. That's pretty much it. And I think that's it for this problem. We'll do one with units in a minute. Let me just zoom out a little bit so that you have the whole thing.